Look up at the night sky. For all of recorded history, humanity has lived on a single world, a tiny, fragile island in an endless ocean of vacuum. But every one of those twinkling lights you see is another sun. Many of them have planets. Some of those planets might even have oceans and life. So the question is no longer if we go to the stars, it's how. How do creatures perfectly evolved for Earth spread out across the entire galaxy? Tonight, we're going on a journey, following the path that real physics allows. First things first, before we can even dream of other stars, we have to learn to live off-world, right here in our own solar system. This means building bases on the Moon, habitats on Mars, and massive rotating space stations. The Moon is the perfect construction yard. Its low gravity makes launching materials into space incredibly cheap compared to Earth. With no atmosphere, heavy industry becomes much easier. We can mine the ice hidden in its craters for water, and then split that water into hydrogen and oxygen. That's rocket fuel, made right where we need it. Once we've mastered the Moon, Mars is next. What starts as a few isolated domes will grow into sprawling settlements, and those settlements will become cities over generations. Humans will adapt. We'll learn to live with lower gravity, protect ourselves from higher radiation, and manage incredibly complex, closed ecosystems. We won't be explorers anymore. We'll be residents. We will have become a true multi-planet species. But the future of humanity isn't just about living on other planets. Planets are deep gravity wells, expensive to get on and off of. The real expansion happens in the space between them. This is where we start building giants. We'll capture asteroids and mine them for metals, iron, nickel, platinum, everything we need to build our new civilization. We'll harvest comets for water and organic compounds, and we'll build O'Neill's cylinders, immense rotating habitats that create their own artificial gravity using simple centrifugal force. We're talking basic Newtonian physics here. Inside these spinning worlds, we can have forests, rivers, and open skies. Millions of people could live their entire lives in space without ever setting foot on a planet. Our population will explode outwards, and industry will follow. We'll have shipyards orbiting Jupiter, factories processing asteroid materials, all powered by the constant, abundant energy of the sun. And now, with a foothold across the solar system, we're finally ready to think bigger. The problem, of course, is distance. The solar system feels huge, but on a galactic scale, it's a single grain of sand. Our nearest stellar neighbor, the Alpha Centauri system, is over 4 light-years away. That's more than 25 trillion miles. If we tried to make that journey with the chemical rockets we use today, it would take tens of thousands of years. Even with advanced nuclear propulsion, we're still looking at a trip that would last for centuries. That's just not practical. To truly conquer the stars, we need to go faster. Not with magic or warp drives from science fiction, but with real physics. And the answer might be to ride on light itself. Light might seem weightless, but it has momentum. When a photon bounces off a surface, it gives it a tiny push. Now, imagine a gigantic, ultra-thin sail, kilometers wide, and a colossal laser array back in our solar system. By focusing an immense beam of light onto this sail, we can accelerate a small spacecraft continuously. We could push it to a significant fraction of the speed of light, at say, 20% of light speed. The journey to Alpha Centauri is no longer thousands of years. It's about 20. Now, that's still too fast and too harsh a ride for humans, at least initially. But for our robotic probes, for our first interstellar explorers packed with sensors and AI, suddenly the galaxy becomes reachable. We can send swarms of these tiny light sail probes to thousands of nearby stars, mapping out systems, analyzing planets, and sending back precious data long before the first human ever leaves our solar system. So, where do people fit in? Humans will follow, but we are much heavier and more fragile than a silicon chip and a camera. So our first journeys will likely be slower. One possibility is the generation ship. Imagine a self-contained world, a massive O'Neill cylinder, but instead of orbiting the sun, it's drifting through the blackness between stars on a journey that will last for centuries. Generations will be born, live, and die on this ship, with only their distant descendants ever seeing their new home. Another option is cryogenic sleep. If we can solve the immense biological challenges of freezing and reanimating a human body without damage, then a crew could simply sleep through the centuries-long voyage. A third, perhaps stranger, possibility involves sending frozen embryos watched over by artificial wombs and raised by AI nannies upon arrival. It sounds bizarre, yes, but all of these concepts operate within the known laws of physics. They don't require breaking the light speed barrier. All they require is incredible engineering and patience. When we do arrive at these new worlds, what will we find? Most exoplanets won't be like Earth. The gravity might be crushing or too light. The atmosphere could be toxic. The temperatures lethal. So the first settlers won't be walking out onto green fields. They'll live in the same kind of habitats they used in our own solar system. Terraforming an entire planet, changing its atmosphere and climate to be like Earth's is a monumental task that, if possible at all, would take thousands of years. A more practical approach is paraterraforming, building massive domes to enclose large regions, creating Earth-like environments under a roof. Humanity will spread not as conquerors of planets, but as builders of self-contained worlds. But here's a twist that many people miss. Who or what will really build this galactic empire? Humans are needy. We require air, water, food, and warmth. We don't handle long, lonely journeys well. Machines, on the other hand, have none of these limitations. The true pioneers might be self-replicating robotic factories. Imagine a machine that lands in an asteroid belt, mines the resources, and builds copies of itself. These new machines then travel to the next star system and do the same. They could spread across the galaxy exponentially, building the infrastructure, habitats, power stations, everything before humans ever arrive. But by the time people make the long journey, their new home is already waiting for them, built by an army of automated workers. Through all of this, there's one speed limit we absolutely cannot break. Albert Einstein gave us the ultimate cosmic rule. Nothing with mass can travel at or faster than the speed of light. No matter how advanced our technology becomes, this fundamental law of the universe remains. This means our expansion across the galaxy will be a slow, steady wave spreading out over millions of years. But new colonies will be founded, and almost immediately they will be isolated by the vastness of space and time. A message sent back to Earth could take decades or centuries to arrive. This leads to a surprising truth. When we imagine our future among the stars, we often think of a single, unified human empire. But physics suggests something radically different. We won't have one future. We'll have countless futures. We'll have countless independent branches of humanity scattered across unimaginable distances, evolving in their own unique ways. They will be too far apart to control one another, too far apart to fight wars with one another, and eventually maybe too far apart to even remember their common origin. The greatest journey humanity will ever take may not create one galactic civilization. It may create millions of new, separate civilizations. And somewhere, far in the future, under a strange new sun, someone will look up at their sky, filled with unfamiliar constellations, and ask the same question we ask today: where did we all come from? Thanks for watching. If you enjoyed this journey into our possible future, don't forget to like, subscribe, and hit that notification bell for more explorations of science and space.